We're going to talk about the big idea of a confidence interval. It comes down to this. Often we're interested in some fact about an entire population. Maybe I want to know something as silly as what percent of the population eats a Kit Kat just by biting into the Kit Kat, or who sits there and eats off each layer. I personally eat off each layer. Okay, so I'm not going to ask every person in the population, so what do? I take a sample, okay? And out of this sample, let's say that of these 6 people right here, 2 out of the 6, just bite into the Kit Kat. Just hack that thing apart, all right? The other 4, like me, eat it off in layers. So what do? If 2 out of 6 are 1/3 of the sample, I can kind of use that to make a prediction that, as long as it was a random sample, then probably about 1/3 of the population do. It gets a little more complicated with that because you know what? Maybe it's not 1/3 or 33% of the population. I'd feel a little more comfortable if I added on a little bit of wiggle room and subtracted the same amount of wiggle room. So maybe I add 10% in either way. So between 43% and 23% on the lower end, between here is what the true proportion of people in the entire population who just bite into their big old Kit Kat, all right? In class, we did a lab that should help you make more sense of these things, but if you missed class, this video is going to go through the highlights. So a confidence interval is written in the form of A, B. All right, so if it's percents, maybe it's 0.2 to 0.32, something like this, 0.20 to 0.32. The point estimate is what you got from your sample, all right? So if I know the point estimate, it's like your middle part, and we have some guess from our sample, okay? And that guess, we're going to add on and subtract from it. So the one that's smack in the middle of these, well, how do I get that? To get something smack in the middle, I add the endpoints, A plus B, and I chop it in half. All right, so in this scenario, this would be 0.26 would be smack in the middle. 20% plus 32% is 52, chop it in half, that's 26. So it's a margin of error that gets added on and subtracted. Well, if I take this 32 minus 26, that's 6% gets added on. So to get the margin of error, I'm going to take my upper end minus the point estimate. Another thing you're going to have to do is interpret confidence intervals. We say we are 95% confident that the interval from A to B captures the true proportion of whatever it is you're trying to do in context, like find what proportion of people just bite into a Kit Kat. To determine if some value is plausible, we check to see if the value falls in the interval. And we'll look at a sample of that. Okay, so polling is where you see confidence intervals all the time. Polling organizations regularly survey U.S. adults to ask if they approve of the job the president is doing. On the day of the 2014 midterm elections, the 95% confidence interval for the proportion of all U.S. adults that approved of President Obama's job performance was 0.39 to 0.45. Interpret the confidence interval. So I've stated that I'm 95% confident that the interval from 0.39 to 0.45 captures the true proportion of U.S. adults who approved of President Obama's job performance. We talked more in class, in the lab, what this 95% confident means. Your confidence is in your interval, that you're capturing the true proportion. If we would build lots and lots of intervals, because every time we draw a sample, we build an interval. So if we did this lots and lots of times, most times we would catch it. What percent of the time? We would capture the true proportion 95% of the time, but once in a while, we would actually miss the true proportion. Now we need to calculate the point estimate and the margin of error used to create the confidence interval. So for our point estimate, remember that came from what we sampled, okay? So we're working backwards. It would be the midpoint, and then you add and subtract your margin of error. So you add your values, chop it in half to find the midpoint. And that gives me 0.42, okay? So from their sample, that means 42% approved of Obama. But the margin of error, sometimes abbreviated MOE, sometimes just ME, is what they added on and subtracted to that 42%. So the easiest way to do this is take the upper part of the confidence interval, the 45%, and subtract the midpoint, that 42, your point estimate. So minus 0.42, that'd be 0.03. That means they added on and subtracted 3% to that point estimate. Is it plausible that on the day of the 2014 midterm elections, a majority of U.S. adults approved of President Obama's job performance? Is this possible? Well, first of all, a majority is 50%, or actually I should say greater than 50%. So what I do is I look at my confidence interval. Is it a plausible value? Is it in the interval? No. Stops at 45%. So it is not plausible. I'm stating no, values greater than 0.5 are not in the interval. So that's a really fast overview of confidence intervals if you missed class.